Hello everyone, welcome to MK Academic Solutions. So in this video, I am going to explain you about the methods to find the order of reaction. Okay, in previous classes, I told that order of reactions and rate equations we can write by doing experimental method only, by using experimental methods only. Okay, so these are the experimental methods which are used to find the order of reaction and also which used to write the rate equation or rate law. Okay, so what are these methods? The first one is hit and trial method, one half dilution method, fractional method, and graphical method, and Ostwald isolation method. Okay, so now let us go to the one by one method. The first one is hit and trial method. Okay, so in this hit and trial method, what we will do, the same reaction we will do several times by taking different initial concentrations and different time intervals. Okay, so the same chemical reaction, the same chemical reaction the same chemical reaction chemical reaction is repeated several times by taking different initial concentrations, by taking different initial different initial concentrations and different time intervals different time intervals time intervals. Okay, so the obtained data, the obtained data obtained data is substituted in different rate equations, which means zero order, first order rate equation, second order rate equation, like that. And here finally what we are going to do, we will find the k value. Okay, so we find the k value, we find the k value we find the k value. So in which equation we are going to get a constant k value? So in which equation in which equation we get a constant value, constant k value constant k value. So that is only the order of that reaction, that is only is the order of that reaction, order of that reaction. Okay, and here we see the units of k, so that by using units of k also we can find the order of reaction. By using units of k, also we find the order of reaction, Okay, so let us see here, we are having different type of order of reactions. Okay, let's see here. So here we are having different type of order of reactions and rate constant value, half-life equation and units. So what is the data we are getting? We are going to substitute in these equations. So in which equation we are going to get a constant k value, that is only the order of reaction. For example, for zero order reaction k is equal to x by t, and for first order reaction 2.303 by log a by a minus x. For second order reaction k is equal to 1 by t of 1 by a minus x minus 1 by a. Like that we are going to use the different rate constant k value, rate constant and k values, and we are going to get that order of reaction. Okay, right. And these are the units of k. I told that by using the units of k also we can find the order of reaction. What is the order of reaction? Okay, right. So now here we have a question which is asked in the JEE Mains 2021. So what they asked, for a reaction of nth order, the units of rate constant is nth order units rate constant. So what is the units of nth order rate constant? See, we are having what is the units of rate of nth order? Nth order. So these are the units. Okay, what are the units we are having, children? See, moles power 1 minus n, liter power n minus 1 per second. Okay, so what will be the answer? So what will be the answer here? This is mole power 1 minus n, liter power n minus 1 and per second. Okay, this is the units of nth order reaction. Okay, right. So or else simply you can derive that also, derive this also. So what is the rate? Dx by dt is equal to k into concentration to the power n. So here dx by dt means here concentration by time, concentration by time, that is equal to k into concentration to the power n. So here which concentration they have given? Moles per liter. Concentration, which concentration they have taken? Moles per liter. So here you take moles per liter by time, that is equal to k. Here also moles per liter whole to the power n. Therefore k is equal to moles per liter by moles per liter whole power n and time. So now when you rearrange this, you will get moles per liter whole power 1 minus n time inverse. So here you multiply this into the bracket, what you will get here? Mole power 1 minus n, 1 minus n. So here liter, here minus 1 is there, this will become reciprocal, liter power n minus 1, here time second inverse. So okay, these are the units of nth order reaction. So it is asked in JEE Mains 2021. Okay, next we go to the another method, that is want half differential method. Okay, so when we use this want half differential method means when we are having only one reactant, when we are having only one reactant or order with respect to one reactant, or order with respect to one reactant. Okay, see, for example, when A is converting into product, so what is the order with respect to A? What is the order with respect to A means we use which method? Want half differential method. Okay, so in this method what we are going to do here, we are going to do the experiments with different initial concentrations and with different time intervals. Okay, so we do experiments with different initial concentrations, with different initial concentration, different initial concentration, and we find order, we find rate of reaction, we find rate of reaction, rate of reaction, we find rate of reaction by comparing them, by comparing their value, comparing their values, we find the order of reaction, find the order of reaction, order of reaction. Okay, so this we will do. See, for example, okay, we are going to take A is gives rise to product. So initial concentration is A1, here rate is equal to R1, and initial concentration is A2, here rate is equal to R2. Okay, so here we already know rate 1 or R1 is equal to, rate R1 is equal to K into A1 power n, and rate 2 or that R2 is equal to K into A2 power n, K into A2 power n. Okay, now let us consider this as the equation 1 and this as the equation number 2. Okay, so now let us do 1 by 2. Let us do 1 by 2. So therefore, R1 by R2 is equal to K into A1 power n, K into A2 power n. So for a reaction, K is also constant, order is also constant. Only concentration changes, rate changes, right? So therefore, this we can write as R1 by R2 is equal to A1 by A2 whole power n. Okay, so this is the important equation, and this equation only we are going to use to find the order of reaction, or else some more modifications here we do in this equation. What are that modifications? So now apply logs, apply log both side, apply log both side. Okay, apply log both side. When you apply the logs both side, what you will get? Log R1 by R2 is equal to log A1 by A2 whole power n. Okay, so now this will become as log R1 by R2 is equal to n log A1 by A2. Therefore, n is equal to what you will get? Log R1 by R2 by log A1 by A2. So this we can write as n is equal to log R1 minus log R2 by log A1 minus log A2. Okay, this in this way we are going to find the order of reaction. So here we know already where n is what? Order of reaction. Okay, so where n is what? Order of reaction. So this is the important equation for us to calculate the order of reaction. Okay, next we will see one model problem on this. Okay, so the rate of reaction starting with initial concentration 2 into 10 to the power of minus 3 and 1 into 10 to the power of minus 3 molar, okay, are equal to 2.40 into 10 to the power of minus 4 and 0.60 into 10 to the power of minus 4 moles per second respectively. Okay, calculate the order of reaction with respect to reactant and also the rate constant K. So here they have given the two questions. What we need to find out? So order of reaction we need to find out. Okay. So order of reaction we need to order we need to find out, and also the rate constant also we need to find out. So what is the given here? Given one is initial concentration they have given, and rate also they have given. Initial concentration and rate also they have given. So now let us take the given data. So here what is the given data? Okay, given data, given data we are going to take first. What is the given data? A1. A1 means initial concentration. What is the initial concentration? 2 into 10 to the power of minus 3. And A2, second initial concentration. What is that? 1 into 10 to the power of minus 3. Okay. And next, rate of reaction R1. R1 is equal to 2.40 into 10 power minus 4. Next to R2 is equal to, rate is equal to 0.60 into 10 to the power of minus 4. Okay, so this they have given, and here this is molar, this is molar, this is molar per second, so molar per second. And what they are asking, n they are asking, what is the order they are asking, and what is the rate constant value k they are asking. So when you observe this type of data, immediately we need to use the Van Hoff differential method. So first formula what I told in the Van Hoff differential method, what is the first formula I told here? See, first formula, this is R1 by R2 is equal to A1 by A2 whole power n. So you use this formula, this will give easily the answer. So what is the R1 by R2 is equal to A1 by A2 whole power n. Okay, this is the formula here we are going to use to find out the order. So here what is the R1 children? 2.40 into 10 to the power of minus 4 by 0.60 into 10 to the power of minus 4. So here molars per second, this also molars per second, that equal to A1. What is A1? Initial concentration 1, 2 into 10 power minus 3, and second initial concentration is how much? 1 into 10 power minus 3 whole power n. Okay, so now when you solve this, so molar per second will get cancelled out. Okay, next here 10 power minus 3 will get cancelled out, and 10 power minus 4 will get cancelled out. Okay, so here what is the remaining value now? So 0.60 by 2.40 by 0.6 means we'll get the 4. 4 is equal to, so 2 power n you will get. 4 is equal to 2 power n. So how we can write the 4? 4 we can write as the 2 square, that is equal to 2 power n. So if bases are same means powers are equal. Okay, therefore n is equal to 2. So what is the order of reaction here we got, children? Second order reaction. This is what, which order reaction? Second order reaction. And the next, what they are asking next here, what they are asking, rate constant value also they are asking. What is the rate constant value? So rate constant value, simply we can do, rate is R1 is equal to k into A1 power n. So this formula you use. So what is the rate? 2.40, that is equal to k into, what is A1? 2 into 10 power minus 3. Okay, so we'll do in the next page. Okay, we'll do in the next page. So here R1 is equal to K into A1 power N. Okay, right? So now R1 is equal to 2.40 into 10 power minus 4 molars per second, molars per second, and that is equal to K into what is A1 they have given 2 into 10 power minus 3 molar, okay, whole power n. What is the n here? We know what is the order of the reaction, that is 2. So now therefore K is equal to 2.40 into 10 power minus 4 molar per second, moles per second, by, so here 2 to the 4, that is 10 power minus 6 you will get, 2 3 is 6 moles square you will get. Okay, so now, so here again this K is equal to, so now you calculate this, how much you will get. Here 10 power 6 goes to the numerator, 10 power plus 6, and here plus 6 minus 4 will come, total it is 10 power 10 square. 10 square, that is 2.40 into 10 square, and here mole power 1 will get to mole power minus 1, moles power minus 1 second inverse by 4. So here K is equal to, this we can write as 240 by 4 mole inverse per second inverse, that equal to how much you will get, 60 mole inverse second inverse. Okay, so this is about what, rate constant for this formula, for this problem. So we found the order of reaction and also the rate constant. Okay, so next we will go to the one more question based on the this one half differential method. So now let us read the question. What the question is telling here? For the elementary reaction, M is gives rise to N. The rate of disappearance of M increases by a factor of 8, upon doubling the concentration of M. Okay, the order of the reaction with respect to M is, so it is asked in the JEE Advanced in 2014. Okay, so very simple question it is. So what they are telling, M is gives rise to N. Okay, so now let us consider initial concentration is X. Okay, and what is the order you consider here? So order also they are not given order. So here A1 is equal to X, and here A2 is equal to 2X. Next here R1 is equal to Y, and R2 is equal to 8Y. Why I am taking 8Y? It is they are telling that increases by a factor of 8. Factor of 8 means we need to multiply with 8. So now we are having A1, A2, and we are having an R1 and R2. So we can find the order of reaction very easily. Okay, so now use the formula, that is R1 by R2 is equal to A1 by A2 whole power N. Okay, so now what is R1? We are going to consider Y by 8Y. So and what is A1? A1 is X, A2 is 2X. Okay, whole power N, right? So now here y will get cancel out, and here also x and x will get cancel out. So what you get here, 1 by 8, that is equal to 1 by 2 whole power N. So here 1 by 8, how I can write here 1 by 2 cube, and that is equal to 1 by 2 power N. So 1 power N is 1 only. So this we can write as 2 cube is equal to 2 power N. Therefore if bases are same means powers equal. Therefore, order is equal to 3. So n is equal to 3. So order of the reaction is equal to 3. So very easy question they have given. Okay. Next method of expressing concentration, fractional or half-life method. Okay. So this also very important. Here what we are doing, children, the same one half differential method only, but here we are going to take the half-life of a reaction. Okay, so we are going to find the half-life of reaction with different initial concentrations, and we are going to compare the half-lives. Okay, right. Okay, so here what is half-life? Half-life means we know that is time required to complete the half of initial concentration, that is called half-life. So half-life of any reaction is inversely proportional to, or proportional to 1 by a power n minus 1. 1 by a power n minus 1. So here we are going to find the half-life of a reaction with different initial concentration. So here what we do, we find the half-life of a reaction with different initial concentrations, with different initial concentrations, okay, and we compare them by using that equations. Okay, so let us consider t half 1 is directly proportional to 1 by a1 power n minus 1, and t half 2 is proportional to 1 by a2 power n minus 1. For the same reaction, this is the initial concentration 1, this is the initial concentration 2. It is the half reaction of 1, half reaction of 2. Okay, so now let us consider it as the equation 1 and it as the equation number 2. Now let us do 1 by 2. So here what we are doing, 1 by 2. So when you do the 1 by 2, how you will get? Equation 1 divided with equation 2. So t half 1 by t half 2 equal to a2 by a1 whole power n minus 1. Like that you will get. Okay, so here, however they are in the recipe, this in the denominator, so that I am changing directly here. Okay, right. So now by using this equation, so by using this is very important equation to find. So by using this equation we can find the order of reaction. Okay, we can find the order of reaction, or else this equation also we do some modifications here and up. So here what we will do, children, we apply the logs, apply the log both side. So when you apply the log both side, what you will get? Log t half 1 by t half 2, that is equal to log a2 by a1 whole power n minus 1. So this we can write as log t half 1 by t half 2, that is equal to n minus 1 of log a2 by a1. Okay, so now you send this a2 by log a2 by a1 this side. So what will get? N minus 1 is equal to, so log t half 1 by t half 2 divided by log a2 by a1. So this is the formula. Okay, and finally how you can write this? Okay, so now let us do some modification here. Okay, so this we can change as n is equal to 1 plus log t of 1 minus log t half 2 by log a2 minus log a1. So this is what a fractional or half-life method. Okay, fractional or half-life method is proportional to 1 by a power n minus 1. Okay, so this is the important formula you remember, and this is also here important formula. Okay, this also here important formula. Okay, to find out. Okay, now let us go to one question here. So the half-life period of a reaction at initial concentration 0.1 mole per liter and 0.5 per mole per liter are 200 and 40 seconds respectively. The order of reaction is okay. So now let us see what is the given data first. So 0.1 mole per liter and 0.5 mole per liter means initial concentrations they have given. Initial concentration A1 and this is you can consider as A2 and half-life period it is t half 1, it is t half 2. So now what they are asked, order of reaction. Okay, so first take the given data. So what is the given data here children? First, initial concentration A1, that is 0.1 mole per liter. Initial concentration A2 is equal to 0.5 mole per liter. Next, initial T half 1. T half 1 is equal to 200 seconds. And T half 2 is equal to 40 seconds. Okay. So therefore, what is the order of reaction? So what is the order of reaction formula? So I told you T half 1 by T half 2 is equal to A2 by A1 whole power n minus 1. This is the formula you use, I told. Okay, so this is very easy to find out the order of reaction. Okay, so now T half 1, what is the T half 1? That is 200 seconds, and T half 2 is 40 seconds. That is equal to A1 by A2. What is A2 by A1? What is A2? 0.5 and A1 is 0.1 moles per liter whole power n minus 1. Okay, so now second will get cancelled out. Second will get cancelled out. Moles per liter will get cancelled out. Okay, so what will get here? For 200 by 40 means 5. 200 by 5 means what will get 5, that is equal to 0.1 by 0.5 by 0.1 means here also will get 5 whole power n minus 1. Okay, so here we are having 5 power 1, 5 power whole 5 power n minus 1 means if bases are same means powers are equal. So therefore n minus 1 is equal to 1. Therefore n is equal to 1 plus 1, that is equal to 2. So what is the total order here? What is the order of this reaction? It is second order reaction. Okay, right. Next let us see one more question which is asked in the JEE Mains 2023, means recent question only it is. So what they have given is pressure in mm of Hg 50, 100, 200, 400. Relative T half 4, 2, 1, 0.5. And what we need to find out the rate of order of reaction. A student has studied the decomposition of gas AB3 at 25 degrees Celsius. He obtained the following data. Find the order of reaction. Okay. So here what we need to do, find order of reaction, order of reaction, and write the rate law. Write the rate law. So this is the question, complete question it is, write the rate law. Okay. So here what is, this is the given data for us. Okay. So now let us consider 50, 100. These two we are going to take. Okay. 50 and 100 we are going to take. So let us consider this is the initial concentration A1, this is the initial concentration A2, this is you can consider T half 1 and you can consider it as the T half 2. Okay. So now do the question. Okay. Right. Okay. So first we find the order of reaction. Order of reaction. Okay. Order of reaction. So what is the order of reaction? Okay, right. So what is the formula? Here we use T half 1 by T half 2 is equal to A2 by A1 whole power n minus 1. This is the formula you use. Okay, now substitute the data. What is the T half 1? 4. What is the T half 2? That is 2 seconds only will get cancelled out. What is A2? That is 100. And what is the A1? 50. Whole power n minus 1. Okay. So for 2 ones are 2 twos are, okay, 2. Here also will get 2. So here, so here 2 power 1 that is equal to 2 power n minus 1. So here also bases are same as the powers are equal. So what you can write here, therefore n minus 1 is equal to 1, n is equal to 1 plus 1 that is equal to second order reaction. It is the second order reaction. And what is the rate law for this? Rate law, it is rate is equal to K into AB3 power 2. Okay, this is about the this reaction. Okay, right. So next, okay, the remaining two methods I will explain in the next video. So up to this, once again you revise and do the some practice question so that you may get clarity and confidence. If you are not understanding any problem, once again you totally you watch the video so that you can get your doubts clear. Okay, thank you for watching.